Hi, everyone. Where you might be around the world and whatever time it is there. Thank you so much for joining us today. For those that attended our session yesterday on the Metaverse, welcome back. And for those who are joining us for the first time, it is my honor to welcome you to TDK Ventures Digital Transformation, or DX Week 2022. The great problems of our time and amazing opportunities they represent, if we tackle them right, can only be handled by coming together. That is what makes moment and event like these so special. Today's session touched on what very thread of us coming together, the connectivity. We have always been a social species, thriving together and progressing forward through collaborations and kinship. Today, that has never been truer, and the digital transformation, there is that DX again, has only accelerated the human connection, even if it is in ways different than we ever imagined. Technology that enables connections continue to spur forward, and the pandemic served as a catalyst in a deep time of need. Today, we get the chance to explore the possible futures of connectivity and the technology that enables it, like faster speed, lower latency, and greater capacity, together with experts from all around the world. My name is Hanrui Huang. I'm the investment associate at TDK Ventures, leading the investment in connectivity and computing space. We look for startups that leverage innovations in fundamental science and apply them to megatrend market like the connectivity to contribute to our society and to our planet. I will be moderating this session today, similar to our format for Energy Week last year and Monday's Metaverse session. We designed our panel to be rounded out with thought leaders representing academia, industry, entrepreneurs, and the investment community. We are passionate about having diversities in each and every panel. We believe this will give us an opportunity for real, meaningful actions. So, speaking of our panel, I'm excited to introduce the amazing guests today and look forward to hearing their exchange of deep insight and maybe some debate. First, from National Institute of Standard and Technology, NIST, we have Dr. Nada Gomez. Hi, Nada.
Hello.
Nada received her PhD in computer science from the University of Maryland at College Park. Since 1993, she has been a research engineer at the NIST. She's an IEEE fellow and an NIST fellow in the Communications Technology Lab. Her research in media access control protocols for wireless network leads to over 200 technical papers. She leads several projects related to the modeling and evaluation of future generation wireless systems and protocols, and serve as the chairwoman for the next 5G Channel Model Alliance. Second, we have Matt Grubb.
Hello, everyone. Glad to be here.
Hey, Matt. Matt is the Chief Technology Officer of XCOM Labs, which develops innovative wireless solutions. Matt previously spent 26 years at Qualcomm in technology and engineering leadership roles. He served as Qualcomm's Executive VP and CTO, overseeing R&D and managing a global team across various divisions worldwide. Matt holds a Bachelor of Science degree in Electrical Engineering from Bradley University and a Master of Science degree in Electrical Engineering from Stanford. Third is Maya Louvgaran. Hey, Maya.
Hi, nice to be here.
Maya is the co-founder and CEO of Movandi, a leader in 5G RF and millimeter wave technology. Movandi is breaking through coverage and network challenges of 5G millimeter wave band. Their solutions aim to solve today's real-world 5G deployment challenges by increase the coverage and capacity while reducing infrastructure costs significantly, accelerating large-scale 5G millimeter wave rollout. Prior to co-founding Movandi, Mayan was instrumental in starting and building the wireless business at Broadcom and in growing it to an annual revenue of over $3 billion. She is an inventor or co-inventor over 280 patents. Fourth, we have Derrick Pepsin. Derrick, hi.
Hi, everyone.
Derrick is the Chief Technology Officer at Boeingo Wireless, a global leader in connectivity and infrastructure. At Boeingo, he is responsible for company's technical vision and strategy. Under his leadership, Boeingo is pioneering the adoption and deployment of the latest wireless technology, including 5G, CBRS, passport, edge computing, network virtualization, and convergence. He is responsible for building and operating Boeingo's core technologies and systems, including web applications, client software, network, authentication, billing, advertising, IPTV, business intelligence, and the overall IT infrastructure. Next, we're joined by Dr. Sanyogita. Sanyogita has the global edge networking at Google. Well, her team is responsible for various cloud networking product, solution, and systems supporting Google's global network. Previously, she was the VP of Product Strategy and Operation at Verizon. Well, she was responsible for incubating enterprise and consumer product driven by emerging technologies. Also, she led the industry-leading 5G network and technology development. Sanyogita's work experience spanned all areas of wireless business, including silicon, network technology, deployment, as well as spectrum strategy. Earlier in her career, she held various R&D and development roles at Lucid Bell Lab, Sandbridge Technology, and Stanford Telecom. We are also joined by Ajit Pai.
Hello.
Hey, Ajit, a former chairman of the Federal Communication Commission, FCC. Ajit is currently a partner at Searchlight Capital, a global investment firm, while he focused on the telecommunication, media, and technology sectors. He is also a fellow at American Enterprise Institute, where he addresses issues pertaining to technology and innovation, communications policy, and market-based incentive for investment in broadband deployment. Ajit's distinguished career at FCC, including 2 leadership roles following presidential appointments. He was appointed commissioner by President Barack Obama in 2012, designated chairman by President Donald Trump in 2017, and twice confirmed by the U.S. Senate. While at the helm of FCC, Ajit had a transformative impact on the future of U.S. technology and communications policy, implementing major initiatives to help close the digital divide, advance U.S. leadership in 5G and other wireless technologies, promoting innovations, protect consumers, public safeties, and national interests, and making the agency itself more open and transparent. And completing our amazing panelist is Professor Mikhail Lipson.
Hi.
Hi, Mikhail, a world-recognized scientist in photonics. Mikhail is the Eugene Higgins Professor of Electrical Engineering and Applied Physics at Columbia University. She completed her BS, MS, and PhD degrees in physics at Technia, Israel Institute of Technology, and a postdoc work at MIT. She pioneered the field of silicon photonics, which is critical for scaling computing and connectivity. She is an elected member of the National Academy of Science and of the American Academy of Art and Science. She was recognized in numerous awards, including the NAS Comstock Prize in Physics, the McCarthy Award, the Blavatnik Award, the Optical Society's Woods Prize, the IEEE Photonics Award, EPFL's Erna Hamburger Award, and the OSA IEEE John Tyndall Award. She has received an honorary degree from Trinity College, University of Dublin. Since 2014, every single year, she has been named by Thomson Reuters as a top 1% highly cited researchers in the field of physics worldwide. She is the inventor of over 30 issued patents. Thank you all, our panelists, so much for helping us to put together the panel and making time to join us today. The agenda and format today will remain approximately the same as yesterday and stay consistent throughout the week. To start are the opening remarks I'm giving now, followed by about 80 minutes of roundtable discussion informed by polling and 2 key questions. The most impactful innovation that can realize in the next 5 years and the most challenging innovation but will disrupt the market in 10 years. Following the discussion will be time for some audience Q&As when some final pollings to summarize what has been discussed and the takeaways. The answers of our panelists will fuel the initial discussion. We will then shift gear to have an opportunity for you, the audience, to get involved. The first way to do this will be your vote on the answers provided by your panelists. Be sure to have your phone or browser ready to vote. So to kick things off for today's session, our first question I would like to present to our panelists is, with respect to the connectivity, what do you think is the most impactful innovation that can be realized in the next 5 years? Please see the link in the chat at the right-hand side of your screen and click through to submit your answers. There should be, I see the link on the right-hand side, some answers coming already. AI and measurement-based wireless channel prediction. Oh, interesting. Wireless fiber and cable. Private network. Faster and cheaper wired and wireless internet. AI and wireless. Just based on the answers provided so far, I see a lot of wireless over there, and also have wired internet. Very interesting. So we have 7 panelists. Any issues for the panelists to provide an answer? Okay. Oh, well, I have one more comes in. AI-enabled automation. Oh, that's a good one. Any panelists have issues to submit answer? Okay, I guess I will pause here. We have 6 answers here. Oh, last thing coming. Everything connected wireless. Wow, that's good. So just looking at the answers, very interesting. Looks like we have a lot of keyword. We have keyword like wireless, AI, and touch the measurement. So looking at those answers, I guess I will throw out the question to the panelists. Matt, if you don't mind, I see a lot of wireless here. I know XCOM is doing amazing innovations in wireless. You come from Qualcomm. How do you see about those answers?
Well, I've got to agree, wireless is a big part of the future, but I'll jokingly comment that the wireless industry has created a lot of wires. But I really do think from connectivity standpoint, I was just talking this morning about the beginning of the mobile wireless internet, and there were some folks who were questioning, why would I want to connect my cell phone to the internet? And why do I need a megabit per second on my cell phone? Of course, we know now that that's not even enough. And we have tens of megabits per second on our devices, but that's not enough. In fact, it's never going to be enough. We're always going to want more. So we're in an era now where we still want to get more capacity, more coverage, lower cost, but also for Metaverse and some of these new use cases, improved latency and improved robustness. So I have to agree with the trend in those responses.
Yes, yes. So you mentioned that the connectivity is not just wireless but wired as well. I guess I will tap on Sayukita. You are leading Google's Edge network, which covers wireless and wired as well. How do you see that comment from Matt?
No, that's a great comment. I mean, I think wireless is, as you know it's one of the primary connectivity for a lot of consumers, like, more so than wireline. If you look at the global industry, out of the 6 billion people, a large proportion of them connect to the internet by wireless means, not by wired connectivity. That said, there is a place for wired as well as wireless connectivity. I mean, enterprises connecting to cloud, enterprises connecting to other enterprises, and so on, requires a lot higher bandwidth with stronger SLAs that maybe it's not possible in certain locations as well as for certain applications. So I think we'll have, every time we say fiber is dead, fiber is back again, because the cell sites also have to connect by fiber, by wired connectivity. There is no getting around to one versus the other. I think it's all of them. The future of the internet is all types of connectivity.
Yes, yeah, that is very true. So if we get back to the wireless side, Nata, you have done some amazing work in modeling the RF propagation. I would like to take what your take on that.
Well,
It all starts with understanding the propagation to make wireless work. So obviously, we've done major, innovations, and we've come a long way. And we still, as we talk to experts, they tell us, it's just the tip of the iceberg. We still have a lot to learn about wireless propagation, but we're taming those waves as we get better at it. So I think, yeah, I mean, I couldn't agree more. The other aspect, I guess, back to your obviously we're all here talking about wireless, and wireless is big, but also, what about battery life? Because here I am connected wirelessly, but I have to be very close to the wall, because my battery, I'm not very trusting of my battery for 2 hours. So, I mean, yes, wireless is good, and it's allowing us to do a lot, but we still have to work on many issues to make it really seamless. And but the vision is there, and we're working on it.
It is true. It is true. So, I see one of the answers provided by panelists is the AI in the wireless modeling. And, looking at that answer, Nata, how do you see AI? What kind of role exactly is AI going to play in the area of the wireless modeling and RF propagation?
Certainly. So I think what we are basically what we're doing today is we use the electromagnetic um, wave theory, and we augment that with physical measurements to make very accurate understanding of an environment. But we measure in environment A, and we go to understand environment B, and we're like, oh no, it doesn't work. It doesn't scale. It doesn't translate. So that's a problem with the current way we're doing this. And in addition, the current cycle of measure, extract to a model, then use the model to design, develop. That takes years, months if we really have a lot of resources, we know what we're doing. But it takes a bit of time. It's a lengthy cycle. So what we're trying to do here with more measurement data and with AI is we're able to measure in an environment and use additional information about the environment with LiDAR, with camera, sensors, etc., and augment that to the RF signal so that we could understand better what the environment is, but we can also use this information in a different environment as we, add the sensing information, the LiDAR, etc. Then we can, understand better what happens in a different environment. So we are looking at two things. One is shortening the cycle for measurement model, use that in the design development to even real-time, prediction of the channel so that we can be more agile and configure and reconfigure faster. But we're also looking at understanding better the environments without having to measure every single environment. So this is where I think AI and measurement data can help us quite a bit.
Yes, yes. So Maya, I know that Movandi is working on the solutions in millimeter wave, and we all understand the challenge of millimeter wave propagation. How would you comment on Nada's comments of using AI to better model the propagation and the coverage?
So let me very quickly go back to the first question you had on wireless and wire. Let me ask a very simple question. Would you like to have wires if you can do wireless, which you get rid of all the wires? I mean, look at what we're doing even in charging, wireless charging. People have been working so hard to get rid of wires because that basically forces you to be limited to where you are, location. So the wireless and the need and desire for having wireless is there. If you could do it today, if you get rid of all the wires and fibers and it was possible, I can tell you it would be done in a matter of instant because nobody wants to go and put fibers and dig. The challenge has been that it's not possible yet, right? Does it mean that it would never be possible? I would argue that it's not the case, right? I mean, you can look at everything in the past history, things that looked impossible, they all became possible. So it's challenging. There are definitely challenges. I'm not arguing that we're going to have fibers and cable for time being, but I can definitely argue as someone who has been in this industry and has done, we've always addressed challenges in the past. This is something that can be done. And that's one of the reasons we have been focusing on trying to address the challenges in millimeter wave, because that's one of the areas that can help with not completely getting rid of fiber, at least for a long time, or cables, but it could facilitate, it could gradually get there. And, all the, going back to what Neda was talking about, modeling, penetration, etc., those are really, really helpful. We actually have been doing some of that very preliminary by using some of the data that have been provided by experts in the research on penetration, etc., to basically develop these technologies and solutions that they have been working on with tier one operators and etc. to try to address the challenges. And again, I think this AI going forward in combination with wireless, it's going to be very helpful in trying to get to the next stages of this, this decade of being able to make things a lot more flexible by providing wireless access to everything and anything and connected work.
Yes, yes. I mean, the way I look at it is nowadays in 5G, millimeter wave specifically, first time humans can have the gigabit connectivity provide without the wire, right? So Ajit, I want to pick up your brain here from the government perspective. You see from both wired and wireless. How would that provide internet access to the population. And even for your current role, I know that Searchlight Capital was looking at making investment in both operators, cable operators, and wireless operators as well. How do you see this will play out?
Well, thanks for the question, Henry. And before I begin, let me thank you and TDK Ventures for hosting this conversation. And of course, my fellow panelists. I have to say, if you ask the question to the audience, and which of these doesn't belong, I would say it's probably me. Incredible technological achievements by each of our panelists. So it's an honor to be here. I do agree with one of the prior comments that each of these different sectors of technology have their place. The world is, of course, going wireless increasingly, but I also think the future is going to be one that will rely on wired infrastructure for some time to come. And I'll start with the wired part. I think that, at least in the United States and many other countries, coming out of the pandemic, there is an unprecedented consensus in most quarters that connectivity, and especially high bandwidth connectivity, is really important, especially at the home. And so, for example, here in the United States, we are seeing an unprecedented amount of public subsidy to support the deployment of high-speed broadband infrastructure, especially in unserved parts of the country. And predominantly, that technology is going to be fiber to the home. And that's, of course, important for residential broadband. But I think it also has important second-order effects in terms of leverage of that fiber for things like wireless backhaul and other types of critical connectivity solutions. So, in terms of the strict question that was posed, the two key criteria I saw in the question were, number one, impactful, and number two, can be realized in the next 5 years. And I do think that the fiber deployment that we are about to see, which is ramping up dramatically, is going to fit those two criteria quite well. And I can't wait to see what it means, not just for consumers, again, in terms of residential broadband, but what that platform of densified fiber will mean for the wireless industry. Speaking of which, shifting to the wireless side, I think there's incredible innovation happening, and you've already heard some of those different vectors, from the incorporation of AI and machine learning to the innovations in millimeter wave and the like. I, for one, am really interested to see how in the next 5 years, the very provision of wireless service is going to be disrupted. And what I mean by that in particular is the introduction of private wireless networks. For the history of the commercial wireless sector until now, the dominant paradigm has been that a commercial operator, typically a very large publicly traded company, acquires spectrum assets from the FCC at auction. It builds or leases wireless infrastructure, requiring a massive capital expenditure. And then it either has to build or lease fiber or other types of similar connectivity for backhaul. And then it essentially monetizes all that expense by providing a service to you, the consumer, or the enterprise. And it's essentially a middleman type of service when you think about it broadly. But now, with the introduction of very different blocks of spectrum. For example, when I was at the FCC, we pioneered the CBRS auction in the 3.5 gigahertz band, which includes not just licensed portions of the spectrum, but also lightly licensed or even open parts of the spectrum. So now you can leverage all types of different spectrum assets. And wireless infrastructure, too, is changing, as opposed to having to have macro cell sites and backhaul, et cetera. You now have essentially a bespoke network, especially one that's going to be virtualized going into the future. And so if you're a large enterprise, say you're operating a big warehouse or a factory, or you're a hospital, it's not inconceivable that in 5 years, you might say to yourself, well, you know what, I can actually build this wireless network for myself. It will be tailored to suit my needs. It can leverage both some of the exciting innovation we see in 5G licensed spectrum, or even some of the 5G NRU or Wi-Fi 6E spectrum that is out there. And we can essentially manage the network ourselves, and we can hold the keys to security ourselves instead of outsourcing it to a vendor. And so I'm really excited to see how different players who traditionally have not been wireless retail providers get into the wireless space and disrupt that marketplace, because I think that the future is going to be one where the wireless network is driven by consumer demands as opposed to being architected from above, so to speak, by the commercial wireless operators.
Yes, Ajit, thank you. Really appreciate your insight. I mean, TDK Venture, we really look at private networks as a future of big opportunity over there, and one of the things I look at is before people they look at the wireless industry is driven by consumer demand. Now we are at the stage of enterprise demand is coming and may be even a bigger opportunity than the traditional consumer demand. I guess I will ask Derrick. Boeingo operates large networks, right? I mean, in building mainly for public use so far. But how do you see the enterprise network coming up?
Yeah, I mean, just to kind of clarify a little bit, we've been doing private networks and public networks for a long time now. So a lot of our networks, in the past, we just had Wi-Fi available for those private networks that we stood up. So whether it was, a retailer in an airport, which a lot of people know us for, who needs to be able to put their point of sale devices online, or cameras, or the TSA, or, if you go through a lot of airports, you see all these ordering devices, or you go into stadiums and you see all the use cases there. Those private networks have been around for a long time. I was a big proponent, just like Ajit was for many years, of how do I end up solving some of these problems, because Wi-Fi was kind of like a hammer that we had to use all the time for everything. And by CBRS coming out, and then, I was also on the board of Multifire. I'm on the board of the Boeingo Alliance too. I'm the treasurer there. But really trying to push the envelope for getting more tools to be able to create these networks. I think that one of the other things we have to realize, as to counter or add to what was said, the idea that each company is going to end up wanting to run a wired, a wireless network of all the different flavors, and then also really able to bring public services for the carriers and for some of those other connections that need to happen. I think it's going to create, this convergence that's right behind me that I talked about in 2014 that needs to happen. But more importantly, the co-integration of all of these networks, and so that your public network can take excess capacity in your private network and vice versa. You're going to end up wanting them to be able to work together, which is going to require a lot of standards development that we haven't done in the past. There's been a lot of patents, and a lot of the people here on the panel have done a lot of patents. I think we need to keep working through the standards bodies to start pushing forward this co-integration concept of all of the technologies, like what we've started with CBRS and the Boeingo Alliance, but it needs to go beyond that. We're working on it with AFRC, with Wi-Fi 6, and there's other things that we need to do so that we're not leaving all this stranded capacity not being used. The other thing I'd just add is I'm coming to you from a satellite connection. I'm in rural America, and I'm able to, no wires here. It's all satellite backhaul that I'm using, and Wi-Fi wireless around this 44-acre farm that I'm at here. And I can tell you, it works. Wireless does work. Sometimes do I wish I had fiber? You bet. But, it does work. And that's another thing that's going to be expanding, that, that when we talk about wireless, sometimes we forget about what's going on in satellite. In 1996, I was working at Iridium, and we thought we had the next greatest thing. It took a lot of years to come to fruition, but it's exciting to see what's happening in that market as well.
Yeah, that is true. Thank you. Thank you for sharing the insight, Derrick. I'm going to have a follow-up question here. So when people are talking about the private enterprise network, you see, there's Wi-Fi technology, there's 5G cellular technology, there's sub-6, there's millimeter wave. How do you see that's going to roll out for private network enterprise?
Yeah, you know what? The difference between the previous Gs and this G is we're focused on the use case and the vision, instead of just creating a backbone that somebody goes and tries to put something on. So when we go into helping out wherever we're at a stadium, and we're saying, okay, I want to have seats there, I want to order food on, I want to have digital signage everywhere, I want to have cameras, I want to have people be able to do their Facebooking, I want to have gaming, betting going on the next shot. All of those different use cases, if you just try to throw them on one technology, it's probably not the right thing to do. So what we try to do first is we map out the different use cases, that journey inside that venue or inside that enterprise. And then once we map that out, then we go, okay, now what do we have available to us? And we start trying to figure out which technology to use. Sometimes, people are putting in Wi-Fi lights, and I'm like, why are you doing that? You're wasting capacity that we might need for other aspects. So put in something around LoRa or some other technology, so you end up not stealing capacity. That's how we do it today. And we end up creating these coexisting, co-integrated to some degree networks. But in the future, with slicing and some of the capabilities that are being developed there, we'll be able to say, okay, now I can just take all the spectrum and kind of balance, and then we come borderless, and we can just shift the use cases from one kind of technology to the other. Now, what that requires, though, is, our phones today have everything in them, but a lot of these cameras don't. So we're putting dongles on cameras that support CBRS, right? So we can do things, whether it's ticketless boarding a plane or monitoring traffic. But you put a dongle on there, and you make sure the dongle just doesn't have CBRS, and it has CBRS and Wi-Fi. So it gives you that backup. It gives you that other opportunity, but we need more of that. We need to be able to put all of it in there so that we have options instead of being stuck in one place or another, and not having these, having many sub networks instead of one big overall network.
Yes. I like the way you look at it. Building out and design a network from the use case perspective. Start from the customer side of the lens. Now I want to get back to the wire side. Mikhail, fiber optics, right? Obviously this is a major component of connectivity solutions. How do you comment the answers we have so far, and what's your view about fiber optics, optical silicon photonics play the role in the connectivity space?
Yeah, I think what we need to realize that yes, wireless is amazing and it absolutely revolutionized our life, but the bandwidth that we consume when we rely on wireless is orders of magnitude smaller than what is needed today in data centers, and not orders of magnitude, but I would say one order of magnitude at least smaller than what is needed for long range data communication. And these numbers are just keep going. Wireless also. They all keep growing. So we need to ask when do we actually stop the wired connection and go wireless? There were a lot of thought in year 2000, a fiber to the home, which do we need that? That's, I think today it looks, it was kind of interesting that we thought about it, that we all thought this was going to be. Fiber to the home. And it was obvious that, let's say in year 2000, it was pretty obvious that the bandwidth was going to go up, but not as much as as actually we need. So anytime you have very high bandwidth, I'm talking about terabit, okay? Very high bandwidth, and you have long length. For terabit, this long length is 1 centimeter. For gigabits, a few meters, okay? Anytime you have these long, relatively long distance compared to the bandwidth and very high bandwidth, you need to go optic. There is just no other way. And that has to do with this kind of fundamental. It has to do with the fact that optics really is the only medium that can carry such a high bandwidth because it doesn't absorb the energy. It's not a lossy platform. So we are seeing it more and more that the wireless, the edge is moving. And optic is becoming more and more relevant in smaller and smaller skills.
Yes. So, Mayan, you touched this fiber and wireless already. Any comments to Mikhail's point?
So, well, again, I believe that wireless is really improving. Okay, and we're pushing the edge. We're pushing the technology. At millimeter wave, you're actually getting, 1 gigahertz, multi gigahertz kind of bandwidth, and you go to 60 gigahertz unlicensed or beyond, you get 6-7 gigahertz. So it does provide huge bandwidth. I don't think that bandwidth cannot support even the backhaul, right? I think the challenge is that, as we go further and further, and we add more IoTs, and add more cameras, we add all these new technologies, the data will grow. So the requirement for capacity and bandwidth and throughput is going to increase. And you do need to have more bandwidth in wireless, or if you have fiber, the fiber has to be able to go to much more bandwidth than probably it can do today, right? So there will be places that you still need the fiber, but I really do think that there are a lot of other things that you would be doing. You can do load balancing, you can do distributed kind of solutions of wireless. So let's say,
absolutely. I think optics is going down, meaning people, we need it now in data centers. We don't need it so much as in the telecom as we needed before. I completely agree. Wireless is becoming stronger and stronger, but the demand on the optics is now off the roof because of all the AI.
Yeah.
So we need enormous connectivity, and that's just using light. But I completely agree that wireless is taking over light or fiber at smaller distances, just because it's going in data centers, just because of
correct. And I do agree with you that in the data centers, as we speak, and more data and all the AI requirement for more and more data in those areas, I think fiber will be playing a big role. And I do agree that AI going forward will be very critical in every aspect of what we do, both locally as well as globally, and all this thing. That requires even more of the wireless in some areas. So the way I envision it, I think that even going back, for example, to private network, right, and indoor applications, etc. I don't believe that necessarily Wi-Fi is going to go away. I think there will still be combination going forward in the future. You will see multiple of these standards playing together. But even those Wi-Fi access, that I believe they're going to include 5G, both mid-band as well as millimeter wave in them, and the mesh network between those is going to be, because then you really need more bandwidth and more throughput. I think that will actually be managed by millimeter wave, which you can make it narrow, shape it. There's a lot that can be done there. And I think as the costs come lower and it's easy to install, it will definitely become like wireless DAS kind of.
Yeah. I think every time you get to the point where you need to do some computing, that's where we all get in trouble. That's but I do agree, for everything else, wireless is just surprising us all.
Yeah.
I think that moves you into edge, and maybe we could, right? Because that's kind of what you're talking about, is what is the edge? Where's that compute happening?
Exactly. Yeah.
And I think, I could take that, but I'd love to hear Google's. Sonia, got to start with that first. I'm jumping in.
Yeah, was it a question for me? Oh, yeah. I mean, well, so the end devices, the consumer devices or enterprise devices, they're all getting more and more powerful. Like things that we would, we have a little computer in the palm of our hands, as we like to call it, right? But the capabilities that we are asking those devices to do is just multiplying multifold. And not to mention the proliferation of data. I think we are just at the beginning of that data revolution. And there's just a lot more data being generated. And what do we do with the data, right? Of course, derive insights from it, make our lives better, make connectivity better, make processes better, improve safety, reliability, and so on and so forth. And all that processing, unfortunately, can't happen at the extreme edge, which is the handheld, or even maybe a little computing device in the home, because we won't be able to scale that. So so here comes the edge, right? The edge, which may be, I mean, I like to think about the edge as multiple levels of edge, right? We have the deep cloud, we have the cloud that is maybe at the, in the town that you are in, or in a large metropolitan area. And then of course there may be an edge inside the home, and then of course there's the device. So I do think we will see a lot of different flavors, and more importantly, data being able to be easily transportable and reliably and with security across all these domains, as well as people. I mean, processes and enterprises looking for active connectivity, right, to the deep cloud versus the edge cloud. We are not talking about, oh, I'll postpone some of my processes to the end of the day, when things can happen, that compute can happen in the deep cloud. I want to be able to manage my workloads across all these different edges more interactively and in more real-time fashion. That's where a lot of the connectivity requirements come in, frankly, and the reliability of those connections, as well as the latency and the bandwidth and all that. That's how it all comes in. So maybe one particular application may not demand it, but when you compound all of these things together, definitely talking about the edge and connectivity being an important part.
Yes, yes. Derrick, you have anything to
Yeah,
add?
yeah, I will. Before I shared when we're developing private networks or public networks inside these venues, I said it's a lot of looking at the use cases and then figuring out what wireless technology you're using. But just as important is that edge and understanding where that edge is for that use case. So if I'm doing micro betting on the next shot that's being taken at a basketball game, we got the NBA playoffs going here. I need that to be able to let people make that decision while they're sitting at the foul line right before they make the shot. I need that edge as close as I can so I can grab all those bets and I can get those bets through before that shot's made. Whereas if I'm trying to, and maybe the same things with some of the health place, the health care facilities that we work with, some of that data and everything you want on premises. So you focus in on the data center at that healthcare facility and how you're going to build that out and how you're going to have connectivity there. And then you go, okay, back to, as we shared, well, some of these things I don't need right away. I'm running multiple houses and I'm a cable player. Maybe I want to be able to provide some of those services, at the metropolitan edge that I would provide, like cybersecurity across the network, et cetera. And so those ones you move out. So that's a big part also of defining and designing these networks today, is not just recognizing, it's part of recognizing that use case, but it's looking at the bandwidth. What am I going to deploy? But also, where am I going to put the compute and the storage? And so you've got to always add extra. We've been doing it since 2012. We just add extra compute and storage in every venue. And we don't know what we're going to do with it yet, but we know sooner or later applications are going to come and we'll have that compute and storage available. And you can see everybody's getting into the game now. All the major cloud players are saying, hey, they're coming out with their own edge device that you can go buy and deploy. And I think that'll be a big part of the next cloud evolution, will be this continued moving compute and storage to be borderless, just like our connectivity is made us borderless with wireless.
Yeah, thank you. Thank you, Derrick. Very good. So to continue this wonderful conversation, and I would like to broaden our horizon. So panelists, now I would like you to consider a slightly different question and answer what you think is the most challenging innovation, but will disrupt the market in 10 years. please see the chat on the right-hand side of our screen. Again, for the link to provide your answer. Reconfigurable service surface to control the wireless propagation channel. Interesting. Integration of sensing and communication. Emerging device with edge computing. We touch edge and enabled metaverse. Biohacking and biojacking. Okay. Convergence of space and terrestrial. Oh, that's a good one. Low Earth orbit satellite connectivity. Ooh. Any panelists want to submit more answers? I'll give 10 more seconds. Okay, all right, we'll have 6 answers here. Now I would like to, continue the conversation. I see Metaverse coming out. I will pick Matt. Again, I know XCon is working on some innovative solutions related to Metaverse. How would you see the connectivity related to Metaverse application?
I'd like to first echo some of the comments. The emergence of spectrum to enable private networks like CBRS has been a great thing. Open network architectures, and I totally agree with like Derrick's comments that one technology family doesn't meet all the needs. But for your question, which was a 10-year horizon and disrupting the market, my thought was an edge compute enabled metaverse with new devices that are built with that architecture. This gets us away from the rectangles that we all carry around. And yet we don't want to have a giant computer that we carry with us. We want to have a powerful processor, yes, but we really want to exploit the benefits of edge computing. And we want to move advanced and heavy processing there so we can have lightweight glasses like this instead of what we have today, which are like that. And to do that, we need these connectivity advances, more throughput, lower cost. Power consumption was mentioned. That's certainly a big part of it. This spectrum for private networks. It's wonderful that we have it. But unfortunately, and I hate to say this, it's not enough. If you have to split, say, 100 megahertz with a couple of private operators, and you want to have a lot of people doing metaverse and exploiting the edge computing, then you need high spectral efficiency. So another advancement is to make the investment in techniques like sensing, channel estimation, those things we just talked about, so that the result can be a better use of that scarce spectrum resource. So in a 10-year time horizon, I'm hopeful and expecting that we will have a new set of devices. It won't just be the rectangles. They'll be very compelling to use, and we'll use the spectrum that's available for these private networks, and the macro operators are doing this too, and then we'll exploit the edge computing. That's kind of the picture.
Yes, yes. Any panelists want to add on what Matt just said?
I'll say that I put that in my 5 years, so I'm hoping we're faster than that. That's what my 5-year I had that, and my 10-year I had this idea that the concept of more biohacking and bio, the bio stuff, the medical stuff, the chips in our brains that most of Padgett knows I shared. I have a chip in my hand that I did about 7 years ago, and I think I'm hoping this gets rid of this in 5 years. So that's the challenge. But I completely agree with Matt. This is hopefully going to be gone. If not 5, I guess 10, but hopefully soon.
Wow, amazing that Derrick, you have a sensor in your body for 7 years already. You are like 10 years ahead of most of us already.
Yeah, I was definitely trying to be creative in doing it, but it's actually working great now. The thought was I'd be able to pay with it, and I was just in Europe last week, and I was paying for the subway with my hand the whole time. So it was kind of awesome to be able to do that. And I think that that's what we're seeing. This touchless experiences that we're starting to create are going to require us to start thinking, not this, but utilizing, our bodies more, and because they're always with us, or rings or whatever we come up with.
Yeah. So speaking to sensing, Mikhail, I know that one application of optics in part of research, if I understand correctly, is not just connectivity but also connectivity and sensing. You have anything to add on that?
Yeah, I think sensing using optics is for areas where you really don't want electronics there in terms of microwave. You don't want any interference, airplanes, for example, and anything that you want to sense that is very, very small, requires kind of a high resolution. Usually the wireless that any sensing based on wireless is it detects things that are relatively loud on the order of centimeters. So, and if you need microns, then you really need to go optics. So I think we need to go both fronts. It's just a different type of sensing.
I see. Yes. So one thing that we touched already, but I want to get a little deeper on that, is satellite communication. Nowadays, with the Starlinks and SpaceX, as Derrick said, I don't know where you are, but your connectivity looks great. And so I guess my question will be, what kind of innovations going on right now, and how do you see that, whether you're going to see the satellite communication will provide a good enough connectivities to the mass population? Any panelists want to take that?
I can. Go ahead.
Derrick, were you about to speak, or was it Matt? I don't know who I stepped on.
It was Ajit. Go ahead.
Oh, it's Ajit. Go ahead. You haven't spoken.
No. Go ahead, Sanjogita. You've forgotten more about the subject than I'll ever know, I'm sure.
No. I keep talking about satellite, going back to a few years, and I think Derrick mentioned Iridium, right? Many years ago, one of my early jobs out of college was working on a broadband satellite system. It was a geo system, and there were multiple LEO programs that were in flight, and they didn't go anywhere. That was several years ago. I'm not going to date myself by telling you when that was, but it was many years ago. Fast forward to now, I think we have come a long way. Technology has come a long way, and I do think that satellite connectivity can be a solution for large chunks of the universe. Of course, there is terrestrial that has leapfrogged over the past several years. Again, I wouldn't say one versus the other. I think we need all types of connectivity. There's always economics of terrestrial connectivity that doesn't make sense in many locations, and satellite is going to be a viable alternative for many home broadband connectivity, right? I mean, like Derrick, I was driving through the United States, and I was in Kansas in the middle of nowhere, and an Airbnb I was at, they only had satellite connectivity, and you could barely send an email. I think we have come, I think things are definitely going to be a lot better than that. And I'm looking forward to the day when we can carry a cell phone and get connectivity everywhere, whether it be by satellite or terrestrial. And that's what I think, that convergence is probably going to happen sometime in the next 10 years, but keeping my fingers crossed.
Yes. Ajit, you want to add on it?
Sure. I certainly can't improve very much on Sanjogita's answer, but I think this is one of the areas that I'm very excited about. When I was at the FCC, we authorized some of the major low Earth orbit constellations that are now making news. Starlink, for example, first and foremost among them. There are others, of course, OneWeb, Kuiper, of course, by Amazon is making massive investments in the space. But I think what I find most interesting about satellite is it sort of derives from the question that was presented: is what is the most challenging innovation? And there's no question that there are some substantial challenges here that any space-based operator has to solve. For one thing, you're just launching the constellations at scale is not an easy proposition. I mean, of course, Starlink is leading the charge in that regard, but even they have only launched a fraction of the satellites that they are authorized to launch. Moreover, there are some challenges in terms of establishing ISL, inter-satellite links, between and among the satellites, so that you can essentially create a very strong mesh network in space to maximize the amount of bandwidth that can be provided and coverage that can be provided. Similarly, another challenge that has yet to be overcome is the cost of the user terminals on the ground. Right now, for example, the leading company, Starlink, offers service, I think, if I remember correctly, a $499 upfront charge just to get the kit. In addition to that, you have to put it in a certain part of your house. It has to be typically on the roof. And if you're in a heavily forested area or there are other obstructions, the service can be interrupted or degraded to some extent. So there are some technical challenges like that, particular to satellites. In addition to that, the space environment is becoming more crowded. In fact, just yesterday, I saw a statement by the administration that they were going to stop sort of these controlled explosions of satellites in space because of the orbital debris it was creating. And we are now reaching the point where if you were to assume that not just Starlink and Kuiper and some of the US-based LEOs launched, but the Chinese LEOs and all the other LEOs around, if they all start to launch, we have a very crowded space environment. Any particular piece of orbital debris could cause serious damage up in space. And for those of you who saw the movie Gravity, you can imagine the kind of damage that can cause. And so I think those are some of the challenges that have to be surmounted. But if we were to stipulate, per the question, that those challenges could be surmounted, I'm really excited about what satellite connectivity could mean. The easy one, and frankly the least interesting one perhaps, is residential broadband. For the billions of people around the world who don't have connectivity today, and for whom terrestrial technologies like fiber might be cost prohibitive or just technically too difficult to deploy, your satellite could provide an alternative. But even in addition to that, if you think about 5G, it's not inconceivable, given the propagation characteristics of 5G spectrum, that you could use satellite to essentially fill in, so to speak, the color for some of those wireless networks. And there are companies focused on that right now, essentially being an adjunct, so that if, for example, your device senses that it can't get connectivity to a tower, it would then default back to satellite, essentially, to get connectivity that way. Or even for some of the enterprises that are out there where you can't see a terrestrial technology being useful. Here, for example, I think of shipping. Some 78% of the world is water, of course, and you have all these ships going on the water. And there are some small space-based startups that are focused exclusively on serving the maritime industry, being able to track every single container on every single ship that goes around the world to maximize efficiency. And you can think of that for all sorts of different, agriculture, things like that. So I think 10 years from now, the space-based environment will be a very interesting one, a very complex one, and one that will serve a whole variety of use cases now that we can't even conceive today. So it's an exciting time.
So let me add something to, Ajit, you were talking about the cost of this broadband that we can actually get from satellite, for example, the Starlink. I think that will remain to be a challenge going forward. I think it's a great thing to have the satellite connection, because there are areas that are isolated and it's very hard to access by any kind of fiber, etc. But the cost of this, because of the distance, and and because my background is actually hardware, etc. I mean, the terminal units for residential being $2,000, and let's say best is coming down to $500, and someone has to come to your house and put it on the roof, etc. Compared to what people are doing today with some of these ISP providers, they're not even using 5G or anything, but like, for example, Starry or some other ones who are using a millimeter wave backbone of even Wi-Fi modem. So there are many other ways that people can get much cheaper solutions for their residential. And I think satellite will have that challenge going forward and will be very limited in the areas and applications that unless you're really rich and you want to spend $2,000, $3,000 on that. But I think again, I agree with you that all these things will exist. I mean, they become more reasonable and they all need to be there, and they will coexist and be back up with other. It's clear. I completely agree with that.
Thank you, Mayam. And I would add to that, I understand cost is one considerations, and also bandwidth and latencies. I
Exactly.
guess we'll throw out how the panel going to look at the latencies of satellite communication. I mean, there's physics out there.
Right.
I mean, definitely that's a consideration, right? And it's again based on applications. There are certain applications that are not latency sensitive, and that can be supported using some of these other connectivity approaches. So I do think you'll have all these. I mean, I keep coming back to the same thing. I think there'll be applications that require that a very low latency, and they'll be on-prem, whether it be private 5G, private with private MEC, and so on and so forth. So there'll be a class of applications that will run on with that architecture. There'll be a class of applications that Matt is talking about that that we need to support very, very locally, such as VR type of applications. And then of course there are less latency sensitive applications that we all use today that can ride on some of these more traditional networks which don't have the latency characteristics that we want. So whether one will displace the other is not clear at this point. I think they'll all exist.
Yeah.
So I'll comment on the latency. I think the LEO constellations that are coming now obviously have a big advantage over the GEOs from the perspective of latency. In terms of the cost, we talked about the terminals and the large antenna. You can shrink that, but then you pay a price for it. You can lower the cost of the user device, but then you pay a price. You may have to increase either the resource in the space segment or lower the throughput. So I think at the end of the day, it's terrific what's happening. There's a lot of improvement, but the reality is the satellite network has a certain envelope that it's most advantageous if it's used in. Remote areas, of course, first responders, of course, those kinds of situations, it's really good. I'm excited about some of the new non-terrestrial network, NTN proposals that are coming where you can use the modem in a smartphone and handle the space channel. Again, you have the antenna issue and the throughput, but maybe for emergency messages or short messages. Or if you put a large, very, very large antenna in space, then maybe you can get more throughput, although that costs a lot. So it's exciting what's happening. As Sanyogita said, it doesn't displace. It goes in its rightful place. We're still going to have fiber and terrestrial networks and local and edge computing and all those things along with.
Well, but Matt, one thing to also remember, you can always go make antennas bigger, etc. But then you have to also you have to be compliant with the FCC and all that. So I don't think you can at the distance they are. I'm not sure you can go beyond. That's one of the challenges what they're having. You can transmit more, etc. But there are other things they can do on the
Yeah, absolutely. I mean, you have to fit within the emissions regulations of a portable, especially a mobile or a portable device that you might hold up to your head. I worked on, earlier constellations like Globalstar and Iridium were derived from cellular. Globalstar was a derivation of CDMA IS-95, and Iridium was more similar to the GSM family. But yeah, even then, the emissions was an issue. And so I don't think we're going to have a day where you just have a cell phone that has the same performance as a 5G phone, but maybe in special conditions, if we go outside and you need to send a message, you'll be able to do things like that.
Yeah. No, I think for emergency, it's great, definitely, because that's the only way you can access anywhere in the world, and it's a great option.
Yeah, I'll just say as a consumer, I want all the connectivity I can have. When I'm out in Baja racing the Baja 1000, I have my sat phone. But I also have a connection on my truck so I can track the vehicle as we're going. And you think about that Baja race before this connectivity, it was dangerous. I mean, it still is, but it's not as dangerous as it was. And I also agree with the maritime stuff. It's huge. At my house, with this 200 meg, I get down, usually it's probably around 120. It's plenty. I mean, I'm, obviously I get all my TV from, non-traditional ways as well. And it's, to me, it's just another opportunity for us to get innovative. And that, to me, is, really the goal of all of this technology, whether it's edge or, all the different bandwidths of capability as we get, is we need to keep spurring forward this innovation. And we'll get to the point where we share, satellite and this and that and the other, and the backhaul is just, we have multiple different backhauls. I think a lot of times today we rely on, that's the circuit's up, and then you have a circuit go down, and if you're in a really important area, that circuit goes down and you don't have any other backup, that's a problem. So thank goodness now we have millimeter wave and some backups sometimes in some of the big cities for that. So we have dual circuits coming and one from one provider, which is fiber, but then we add a second connection when it's in those critical locations like a hospital, where we're ending up using millimeter wave, and we're taking advantage of some of the capabilities that are coming with fixed wireless. And I think that's, to me, the key is we got to keep progressing and inventing with these technologies. And satellite, I think, will continue to improve. I mean, like all of us talked about, I remember the first Iridium sat phone I touched in '96, and I was like, wow, this is a brick. And now I have an Inmarsat satellite that I carry with me pretty much every time I go outdoors or I'm on a boat or something. And it's amazing that I can communicate. When in the old days when I was in the military, it was like fire up the HF radio and see how far I can get. So it's gotten pretty awesome over time.
Yeah. So I agree that, thank you, Derrick, is, when it comes to connectivity, we really need all the tools in toolbox. One subject we touched a little bit, but I want to get back to it, is AI. So the way I look at AI is, so it drives a lot of use case for connectivity, but AI itself gonna, make a big impact to the connectivity solution of connectivity significant as well. I think one of the answers we got before was the network automation. I want to throw it out to the panel that, how much network operation we're going to see in the next 5-10 years because of AI. Anyone want to take this?
So I don't work for an operator. Oh, sorry.
Go ahead, please.
I surmise that it's already happening. Operators are already using AI to do a bunch of things, from load balancing to resource allocation to a number of things, because they have the data and they've been using it. At least that's what I'm told. So who doesn't have data is basically the researchers that would like to get data in order to develop algorithms, the latest and greatest. At least that's what I think. I don't know, but I want to hear from the people who have data, such as, a lot of the folks on this panel.
Sayogita, I see that you want to say something. You come from Verizon.
Yeah.
Google.
I know. I was at Verizon. I'm no longer at Verizon. I'm generally going to talk about the industry, right? I do think that there has been a lot of improvement. The standards themselves have provided a vehicle to be able to add smarts to the network. How the industry optimized 3G networks, how they built 4G networks, and so on, going to 5G. I think there's a lot of automation. There is a lot more intelligence in the networks as well. If, for example, self-organizing networks, the SON concept in 4G came in early, but it wasn't implemented to the full degree by the industry because of how the network is built. But now you're talking about Open RAN, all these capabilities that provide further incentive to be able to build those networks and also run those networks using tools that do not involve manual intervention in many cases. So I do think that if we have to talk about building large networks with the capabilities that we want, taking out the manual optimization is an important part, and the industry has come a long way, but there's still a lot more opportunity.
Yes. Yes. Anybody want to add on this subject?
I'll just say what Nada said. Yes, we're taking advantage of AI today. I can tell you that 12, I don't know, however many years ago, 10 years ago, when I started running Wi-Fi networks at Boeingo, I was like, oh man, this is a pain, because I just didn't have the data insight to be able to manage it like I had when I was working in the licensed realm. And so we ended up developing a lot of automation, a lot of tools. So you've probably seen it. It's great improvements. So you think about it, I have one access point outside of a gate and 400 people get off of a plane. And the first thing they do is all their phones connect. And it's like, what are you going to do? How are you going to manage that? When I only had 20 people there before, some of them on Netflix doing email, and all their devices are built to, as soon as they connect to Wi-Fi, start updating all their apps in the background. All right. And that's going to destroy the bandwidth for everybody else doing everything else. So what do? Where you put in network smarts, and thank goodness we're allowed to do that now. So the FCC helped us there, but we put in the network smart so we can do things like, hey, that background updates you're doing to your devices, throttle that down to 168 kilobytes or something small, so that I can end up letting that movies keep going. And that movie that you were streaming, instead of letting it run at 20 meg, it doesn't need 20 meg to stream on your phone or on your device. Throttle it down to 4. Now everybody gets off that plane, all 400 people are served. Those are the kind of smarts that we now built that dynamically recognize what's going on a single access point and makes those shifts in the network. And those are the kind of things we've got to continually doing. And you know, some of the new DoD tranche stuff that's coming out in the trials that we're working on with several of our partners are not only focused on doing that at the Wi-Fi level, but across all the different technologies. So if my cellular network is in trouble, my private 5G network, go switch over to Wi-Fi and do that all dynamically, based on user, based on priority, based on application, based on actually down to the packet level is where we're getting in some of these solutions.
Wonderful, wonderful. Hey, panelists, thank you all for sharing your thoughts and vision with us through the answers. But to make sure there is ample time for audience engagement and feedback, I would like to take the opportunity now to open up the floor to the audience. Everybody watching, to start with, like, everybody to take out your phones and scan the QR code available for use, the options on the screen. Very shortly, you will be able to, it showed up already, to vote on the answers and convey your support or interest in those you found most exciting ones. We're going to do this for each questions presented. As you see the QR code coming up the screen, you should also be able to find the link in the chat sections on the right-hand side of your screen to go to a polling page. You will be asked first what industry sector you are joining from, followed by a new page where you can vote on the panelists' answers to question 1 that you found most interesting. So I see votes coming. Have a good blend of startup, industry, investors. More people from industry joining. More people from industry. So today we are, privileged to have a very well-balanced panel here. You look at our panelists coming from industry, academia, and government, startup, investors. Let's see how the audience is. Okay, so the poll ends. The result is, the poll started, sorry. So we'll have 1 minute for people to make the poll. I'm not sure whether people can see the font is small to me. Um, so okay, AI and wireless have the largest vote so far, and private networks looks like everything everything connected, I guess. I'm trying to see here. I think AI is leading here. Um, okay, poll is closed. So now this is the answer. I would leave this to the panelists to make a comment of what do you think about the result?
I think it makes perfect sense because after spectrum, the gold for wireless is data, and AI is basically enabling us to use the data, so they make the best of the technology in wireless.
Okay, yeah. So we have a second poll coming up for the second question, the 10-year innovation. We're gonna finish that, then the panelists gonna engage to discuss about the response of two questions. So this is the same voting. You're gonna use your phone or the link on the right hand side. Audience can input your industry sectors and the result. Is it possible we can make the screen bigger? Biohacking, satellite, and edge computing.
We still have to ask question 2.
Okay. Response coming as what the audience, I think the most challenging innovations that will disrupt the market in 10 years looks like the edge computing and Metaverse has the highest vote here. Okay, the vote is closed. So it looks to me that for the 5-year, most of the audience pick AI, and for the 10 years, it is the Metaverse. Any comments from the panelists?
Well,
Any,
I mean, I agree. I agree. I think data and data-driven intelligence is permeating everything we do. So, wireless networks are as complex as you can get, and there is a lot more, lot more that needs to be done on that side. I mean, NEDA kind of articulated some of those challenges that are still being addressed. The wireless channel is not an easy one. Um, you know, Traditionally, there's been a lot of modeling used in understanding the wireless channels. So AI is definitely an area of a tool that many researchers are using, and I don't know that they have made their way into commercial systems yet. So there's definitely that. Then, of course, network automation, making planning easier for wireless networks using deriving analytics from various parts of the network. That's definitely another big area that growth area, in my opinion. And then, of course, converging all those different tools that people use and engineers use on the wireless side, and to be able to convert them into smart autonomous networks is definitely a big open area. And then the way the networks are evolving, the standards are evolving, and the architecture is evolving with Open RAN and so on, provides that capability to be brought in from various different providers, startups, or contributors to the space. That's my 2 cents there.
Thank you.
I mean, my 2 cents, which are worth much less than that, is I'm just happy that low Earth orbit satellites got at least 1 vote since I suggested it. So I'm glad it wasn't 0.
Yeah, I would just like to throw in, I think medical, we talked about it briefly, but I think medical is key. We just went through this pandemic. We ended up trying to figure out how we were going to keep track of, people who are sick and who are not. And the data that we had available to us, I think we're starting to find wasn't as good as it could have been if we ended up having, more data there. I mean, a lot of us have watches that keep track of, our heart rates and everything else, and that our temperatures and, oxygen levels in my latest Garmin watch, those are the kind of things I think that, I hope that we start taking advantage of, that we would have hopefully prevented some of the missteps that we made in addressing, this last 2 years. And so, I would hope that we see that improve too, and we find ways to take advantage of all that data and that AI and the wireless capabilities that come from those emerging devices.
Yeah, that is very true. Mikhail, you have anything to add?
No, it's just very surprising for me, but that everybody is so cohesive, that there are very specific direction that is very clear we should be going.
I guess I have a question. So for Matt here is, you see the metaverse goes to the 10 years answer. Do you see it's really going to take 10 years or, 5 years we're going to get over there?
Well, and Derrick commented on that too. I hope it takes less than 10 years. In my mind, though, some aspects of it are very challenging. The device itself, and in particular the optics and how you do augmented reality in an outdoor setting and have it look good and be registered to the real world, that's a tough problem. I mean, it's being worked on, but that's a tough problem. Being able to upgrade the network, not just at the demo center, but for all of society in outlying areas everywhere, to have the kind of throughput and performance you need to get these experiences. So I do think it will happen faster initially in some areas, but in terms of providing it ubiquitously with devices, again, that are like this and not like this, I think it'll take some while, but I hope it comes faster.
So what are the early use cases you see for Metaverse? I mean, gaming is the one very obvious, but what are the other ones?
Well, there are many. I mean, gaming and entertainment is a good one, but so is education and training and simulation and diagnostic of problems with equipment and machines. And then there's a family of technologies that are similar to Metaverse, but can be used for teleoperation of semi-autonomous vehicles, things like that. So there are many applications. Of course, entertainment is one of the first ones that we read about.
Yes. Now for the last bit of the time we have left, the floor is open for the audience Q&A. Everybody, please feel free to post your questions in the chat, and we will try to get to as many as we can. Okay, we get one coming. From Catherine, what are the cybersecurity strategies for future connectivity, especially with larger data and larger risk of data securities? Oh, that's a good one. Who wants to take that?
I guess I'll jump in. It's good because I'm waiting on everybody else. All right. So I think it really boils down to, and some of you have probably heard me say this, we're creating these networks for the experience of individuals. So I call it, the internet of my experiments, or IOME, instead of IoT, which is just a thing connected. Who cares? Or the other kind of connections. So when we start creating experiences for others, and we start having privacy come in, like GDPR and CCPA, and now Brazil, and is launching one, and we're going to see more of these. We've been surviving on this idea of opt-in and opt-out in how we're allowing ourselves to be able to take advantage of this large data sets. And we're getting pushed back saying, you know what, that's not the way you should be doing it, because you're creating this huge page and you're saying opt into this thing that I can't understand. So I think what we're going to have to do is we're going to have to create a strategy for a future is going to have to be to give that control back to the individual, but we're going to have to make them aware of why we need that data to be able to create these smart experiences we're creating. And so I've been pushing and trying to push it in a standards group. I haven't found one to pick it up yet. This concept of instead of opt-in or opt-out, but opt-aware. And that way, what we do is we give people access to the data that we're collecting on them, so that they can end up pulling it down when they want to, and allowing that go back to each individual. And there's examples by companies that are already doing this. We have the same capabilities as well, where we're trying to give a website where you can go in and you can say, hey, I know you're collecting data on my location as I'm going through, for example, an airport, so I can get a better Uber ride faster. And then if you don't want to be a part of that, you are aware of that and you can go in and remove that data collection. So I think that's, at the end, we're really talking about the data, and that data needs to belong, or it belongs to somebody, and they need to have, we need to find ways to get control back to the individual.
If I may add, I think Derrick brings up the point of more data privacy. When we talk about cybersecurity, we are talking about data in motion that is at risk of being cyber attacks and so on and so forth, right? So if you fundamentally look at like the wireless network, the wireless standards, the base, the radio access network connectivity is extremely secure. And a lot of the stuff that happens is usually at the application layer. So the concept of zero trust networking is one that is being used in a lot of the applications and connectivity, whether it be any kind of connectivity or wireless. The concept of zero trust networking is primary in terms of managing cyber security risks, and as the number of connections go up, clearly there is more and more the probability, given a probability, there is more chances of attack happening. So that's an area that is constantly evolving in my opinion.
Yes, absolutely. Any panelists want to add on this question? Okay, so there's one. Sorry, I didn't get.
Oh, no, not at all. The only thing I was going to add is that I think 5G will be different from predecessor technologies in part because now there's a conversation about security at the outset as we're at the beginning of deployment, whereas in previous iterations, at least from a regulator's perspective, it seemed like it was sort of an afterthought. It wasn't really thought about it when we were creating the architecture of the wireless networks of the past. And so right now you see very active conversation in Washington about how should we support cybersecurity efforts. For example, should there be an affirmative push for specific cybersecurity regulations, like the NIST framework, for example. When it comes to things like open radio access networks, there's been a conversation about security, and are those more secure? And if so, should we encourage ORAN and vRAN technologies as an alternative to the full stack hardware vendors that have been deemed relatively insecure? And so I think it's going to be a very interesting conversation between government and industry to figure out the way forward. But I think the question is absolutely right. With all of this data flowing everywhere and with an ever-increasing quantum of data that we generate, it's going to be even more critical for these next-generation networks to think about security at the beginning of the conversation, not at the end.
Yes. So while you're talking, I start thinking, we didn't really touch that point, Open RAN, right? So I threw this question out to the panelists. Do you see Open RAN will make the network more vulnerable for cyber attack, or as an opportunity for us to make a better network for cybersecurity perspective?
I want to say that Open RAN is about an approach to desegregate the RAN. It doesn't say necessarily anything about security. So security is still has to be looked into and figured out. It does give you sort of the under the hood ability to look at, piece by piece with the different functions, but you still have to, make it secure. So, we can't just go from Open RAN to security in that's just one transition. So we would still have to apply the same risk and based analyses to make sure that it is secure. So I know people tend to put the two together, but I think coming from NIST, we sort of like to say, yes, Open RAN is an approach. It's great. It was sort of the way forward, but it is not necessarily say anything about secure just because it's Open RAN.
Very good. Very good.
Yeah, I would agree with that, but I'd also say some people say that because you're open, you're less secure, and I would disagree with that too, right? And I think it's both those sides. It's not that because it's closed, it's more secure. I mean, we've seen hacks happen. You've got the same amount of smaller, perhaps number of programmers working on a solution and making mistakes. Whereas if you have a open standards-based approach, you've got more people kind of feeding in to make those improvements. So you could have the argument either way. And I think at the end, it's really about just having great practices. It's the security is all about having those good practices and following good practices that we all know to make sure that we have secure networks and secure applications.
Yes, very good. Thank you. So the next question goes to Ajit. So how do you see the impact of regulation on disruptive innovations? If you were FCC chairman after hearing today's discussion, what action would you take to accelerate the deployment of emerging devices having edge computing and Metaverse tech, which is the highest vote for 10 years, right?
Yeah, very interesting questions. And I should start by stressing that I'm very happy in civilian life, so there's no prospect of me returning to my previous role. But just as an academic exercise, I do think that regulation can have a positive and a negative impact on disruptive innovation. The negative ones are very easy to see. I think that government typically, and I saw this certainly during my time at the commission, views innovation as something to sort of pigeonhole into existing regulatory categories. And the easy examples for a layperson to understand would be, is Uber a taxi company or is Airbnb a hotel company? We should regulate these new players in a traditional way, and that can have the unintended consequence over time of inhibiting innovative companies or innovative technologies, at least. And so that's one of the things I do worry about coming from Washington and from Europe, et cetera, that we won't embrace disruptive innovation given the potential benefits it could have, but instead view it as a threat. And so there's been a lot of discussion, for example, about Web3 and cryptocurrency, and whether this could ultimately be an alternative asset class that could benefit consumers in unthinkable ways in terms of giving them ownership over digital assets that they don't previously enjoy. And there are some regulators, for example, some have criticized the SEC, the Securities and Exchange Commission, for being too forward-leaning and trying to restrict or bar certain types of cryptocurrency innovation there. Same thing but I also think that regulation can have a very positive impact on disruptive innovation. Here, for example, some of the conversations we've been having about wireless, we are able to have those conversations in part because the FCC, at least in the United States, over many years, including the last 4, has done the hard work of putting in place the basic building blocks of innovation. Huge bands of spectrum, for example, for licensed commercial operators, a massive amount of a 5x increase in mid-band spectrum in the 6 gigahertz band that innovators can use from 5925 to 7125 megahertz. And so we were able to push these assets into the commercial marketplace and let innovators figure out how best to use them with a flexible use model, which is a very positive thing. The other thing I think that government can do to promote disruptive innovation is to make access to capital much easier. And I think that's one of the things that is critical for any startup, of course, but especially in the current environment where there's all kinds of macro uncertainty. And when there's an inflationary environment with potential low growth, you could theoretically, and we're seeing some initial signs of that, see investors start to shy away from more of the, for example, so-called VC bets, where you might invest in 100 companies and all 99 or 100 might fail. And so I think that we want to make sure that that pipeline of capital continues. And I think it's going to be important for regulators to think about ways to ensure that. The last piece I'll mention as well is making sure that we carve out a place for places like the United States to remain a home for innovation. And this might seem kind of off topic, but it's a personal thing for me. I think historically America has been a great home for people around the world to come and to study and to create and to innovate and to invest. And I think America is at its best when we invite people from every background, from every country, to set up shop here, to create the disruptive innovations of tomorrow here, so that we can benefit from that culture of big think and entrepreneurship. And that's not something that necessarily has to happen in the United States. It could go to other parts of the world. And so I think it's important for countries like the US to focus on making this an attractive home for all kinds of innovators.
Yes, thank you, Ajit. So we have two entrepreneurs here on the panel, Matt and Mayan. How do you see from the entrepreneur startup perspective the role of the government that can help your company to innovating and commercializing the innovations?
I believe government can definitely play a big role in helping the innovation with the startups, especially at this point of time. I did a lot of research initially. My first startup, Innovent, was based on some of the research I performed at the university, which was basically enabled this whole connectivity inside phones, right? I mean, without that research and enabling radio designs and integration with digital in a very low cost fab to bring the cost and power down and make SoCs available, none of these connectivities inside the phone would have been possible, right? So we did a lot of research at that point of time. I think universities were getting a lot of funding from the government as well as many outside companies. I am not sure if that is happening as much anymore, as much as it used to be in the year 1998 and 1990s. I think companies were contributing a lot more to the research in the universities, and I think also government was giving more money at that time as well. So right now, I think one of the things that government can do is definitely contributing more into the university research. But beyond that, when companies start and they're small, they do require funding, and there are things that may be advanced and maybe years ahead. It's not immediately needed, but they're very critical and crucial for the advancement of for example, this whole 5G, what happened in the US versus in China, spending a huge amount of, so I think government generally can help some of these startups to some level, at least initially to some funding, and it would be useful to them as well in some of the applications they do have right away, and eventually for commercial. And it's becoming even more and more because all these big companies are becoming $1 trillion, etc., having so much money and going and trying. So it takes away from the environment where you can get the best talents, because you have to compete with huge companies who are spending a lot of money on taking away resources, etc. And at the end of the day, I actually had a big team at big companies. It was great. We were doing, but there is always things that you can focus on and you can innovate more because you're smaller, you're focused, and that big companies have a hard time to do, no matter how many resources they have, because it gets harder to manage to do everything. And it's very important to keep these startups fund it, help them, and make sure that they get what they need so that they can bring the new ideas and then, help the industry.
Yes, that's very true. That's very true. We have a question coming from Ian. When will LEO connectivity hit a price point to enable emerging markets, similar to how cellular eclipsed wired telephones in countries with less developed infrastructure? So there's a lot of interest from the audience on the satellite side. Who wants to take that?
Well, I can make a few comments. I think, like
Go
we
ahead.
were talking earlier, I mean, the technology is improving and the prices come down and the capabilities increase, but that's also true for terrestrial. Terrestrial networks are improving also, and devices are becoming low cost. So I don't foresee LEO displacing terrestrial networks, but it still continues to become relevant and increasingly useful in the right envelope of conditions, like we talked about, remote areas and also emergencies and first responders and those kinds of things. So that's kind of how I view it.
The scale drives prices down, and with the advent of many more layers, I mean, unlike terrestrial, though, satellite technologies are very are proprietary. So that's one of the probably a little bit of a hurdle in terms of driving costs down at probably the same rate as we can for the terrestrial industry, because just the volumes are significantly higher. But nevertheless, it's still going down, and it's starting to become an attractive proposition for a lot. Like you saw in Ukraine, as soon as as the war started, there were many Starlink terminals coming up in people's homes. So I do think that that's definitely a class of broadband that is going to be affordable for people as an alternative.
Yes, very good, very good. Thank you. So the next question is from Gita. Will the rise of quantum computing dramatically change the connectivity industry? I will throw the question to Mikhail. Would you make some comments?
Yeah, I knew you were gonna ask me this very hard question. It is hard because I think it's for the first time it's having such a big response in the market. I mean, like we heard, I mean, there are companies now that there are several companies that are worth billions based on promise. It's still only promise, but the promise is so high that I think, and the progress has been really there definitely progress, very significant progress in the past, let's say 5 years. If I would have to bet, I don't think we're going to see any quantum computing or quantum applications in general replacing current technology in the next decade. But after that, probably.
Good. Anything else the panelists want to add to Mikhail's comments? Okay, I guess I'm going to move on to the next question, which will come back to wireless. The propagation of millimeter wave is really challenging. This is from Lena. It doesn't go through walls, windows, or trees. Can we overcome it? Would the advanced beamforming help? I guess I would probably start with Nada, because you're an expert on the propagation.
I don't know if I'm an expert, but I've seen a lot of data and measurements. Yes, it's true. There are challenges. Yes, we can overcome some of them. But some of these, limitations may be good, because if it doesn't penetrate through walls, maybe it's good for interference mitigation. And it's also good to see it more as, we don't need millimeter wave everywhere. And as we said earlier, there could be place room for different frequency bands. The idea is that we have millimeter wave as a way to add to our toolkit so that we can, where it is most appropriate, we can use it. So the idea is not about, this frequency or that frequency. Oftentimes, people, put together is like, oh, 5G, that must be millimeter wave. But no, 5G, it's about a big frequency spectrum that we're going to use. Millimeter wave is a big part of it, and will be a big part of it going forward. But I think, yes, there are some challenges. Yes, we can do more to understand the environment, and measurements are a great way to do that. But I think we have to be smart in that, and how we connect things and what we use.
Yes, thank you. Mayan, you want to add on it? Because you are expert in millimeter wave as well.
Well, I completely agree with Neda, but also mention that first of all, I think that some of the limitations of millimeter wave are actually helpful. As she said, when you're inside, indoor, there are two advantages. First of all, you're not creating interference for outdoor, for example, the cellular network, and at the same time, this whole security, etc., that you're talking about, you're limiting it. You're not actually. It becomes even more secure. Secondly, there are ways. Again, you may not be able to change the penetration to some material, but you can definitely extend the range, extend the coverage. And those are some of the solutions that Mubandi we have been working on. We have very low cost extenders, which are smart enough, and they can extend the range from G node B to bring the signal even over the window to your house and make sure that you get coverage inside the home, because these are almost like Wi-Fi access point size devices that you can put multiple of them around the building, and a low cost, and make sure that you get the coverage inside. So there are ways you can go around the building with this kind of extender. So there are definitely ways that you can get around it, and they are being evaluated actually in trials and deployment by some of the operators and companies.
Yes. Matt, you want to add on that?
Yes, thank you. By the way, I totally agree. Those are great comments. I think millimeter wave is a blessing and a curse, and you have to use it properly. The blessing is there's a lot of spectrum. The curse, it doesn't propagate very far, and we're not going to overcome the ability to go through a metal box. But in terms of overcoming being able to use it effectively, the answer is yes. And using multiple transmitters, especially when they're increasingly low cost, is an example. And being able to exploit the fact that you can reuse the spectrum spatially very often is a huge win. That lets you do large numbers of metaverse users, and then right next door you can do it again and again and again. So, I think there's a lot of promising aspects to this. It does take some work to get the costs out and to refine these models and how we use the propagation as a tool, but this is all happening and it's all good.
Yes. Thank you, Matt, for your insight. We really had a lot of great discussions today on important subjects like AI, Metaverse, edge computing, millimeter wave, 5G, LEO communication, fiber optics, and even quantum. The list can go on and on. I think the amazing part of connectivity is to connect. As you can see, our panelists have already connected many dots together just in the past 2 hours. As the saying goes, time flies when you are having fun. And in this case, I think I can speak for many of us that I will be leaving this session more informed than when we started, and even more inspired about the possibilities of the future. I want to extend one final and sincere thanks to our panelists for their time and expertise and sharing their passion with us. And to all you out there watching, asking, thinking, and dreaming with us, thank you so much. None of this would be possible, nor the actions that may follow, without all of you. Thank you.
Thank you, Henry.
Thank you, Henry.
Thank you.
Thanks, Henry.
Thank you. Bye-bye.
Thanks, everybody.
Bye.
This is the second day of the week-long DX conference. Here is a reminder to check out the remaining sessions on edge computing, Industry 5.0, and the future of mobility. Tomorrow in particular, with the edge computing panel, you are going to see world-class leaders from academia, industry, government, and investors to discuss how we can bring together a better future for all of us with innovations in edge computing. Actually, we have already touched a bit on computing today. I would personally be interested in hearing how tomorrow's panel will comment on some of our discussions happened just now. This session is coming to a close, but the important discussion should continue. Please scan the linking and WeChat QR code to join and contribute to this engagement on digital transformation, even after the event concludes. If you would like to share about DX Week, feel free to use the hashtag DX Week 2022 on LinkedIn. Also, feel free to check us out on social media. And until next time, from all of us at TDK Ventures, good morning, good afternoon, good evening, or good night. Thank you again to our panelists and to our audience. And we hope to see you tomorrow. Bye-bye.